this is a video about price elasticity of demand. It also look at the relationship between elasticity and total revenue. So it's unit 2.5, still of course in microeconomics. We know from basics of supply and demand, that this so-called law of demand, that the price will impact on the amount of consumption of a product. So the price increases, demand contracts. The price goes down, the demand is going to extend. And what we don't know at the moment is the extent to which that demand will change. Will it change by a lot? Will it change by a little? And that's where the concept of price elasticity of demand comes in. And the definition there is that it measures the responsiveness of demand to a change in price. So it's one of those areas of economics where both HL and SL calculations are required. So you need to be familiar with this equation here. This is how you calculate PED, percentage change in demand divided by percentage change in price. Now, it might be that you're given the information as a percentage change. Like you might be told the price increases by 10% and the demand falls by 20%, and therefore you can just put those numbers into your equation and calculate the PED as being equal to -2. Or you might be given the numbers as the price goes up from $10 to $11 and demand falls subsequently, and you need to substitute those numbers in and work out percentage change. Percentage change is just the change in the two numbers divided by the original number multiplied by 100. The value of PED is crucial, and so this number here, -2, or the number that we calculate from the PED equation, gives us a lot of information. We know for sure that because of the law of demand, if the price goes up, demand goes down, vice versa. It's an inverse relationship, so you're always going to get a minus sign. It's always going to be negative. With PED, we tend to ignore that minus sign. We just look at it in terms of absolute numbers. So the absolute number for -2 is 2. So we would generally just talk in that sort of language with PED. It tells us the extent to which the demand has responded to the change in price. So whenever PED is greater than 1, we say the product is elastic, it's responsive. Right? More than that, it means for every 1% change in price, there's been a 2% change in demand. So if PED is calculated as 5, then a 1% change in price leads to a 5% change in demand. It's even more elastic, it's even more responsive. We can start to look at the shape of demand curves as being elastic or relatively elastic, relatively inelastic. This one's fairly flat. It's quite responsive to price, a smallish change in price. Let's say from here just down to here actually has a more significant impact on demand because the demand curve is fairly flat, fairly elastic. Another example might be this one. If an increase in price of 10% causes a 5% fall in demand, we're going to get a PED here, -0.5 or just 0.5. Same relationship. For every 1% change in price, there'll be a 0.5% change in demand. But it's inelastic. It's not as responsive as it was before, and therefore the demand curve is going to be much steeper, right? Relatively steep, relative in terms of comparisons to other demand curves. Excuse the line that's gone a bit sloping, but you can see that the change in price doesn't have as big an impact on demand as we saw in the elastic diagram. There's a number of, you can practice the calculations, and you should do that so you know how to work out PED fairly comfortably. Just be careful with making sure you get demand on the top, price on the bottom, right? And it's always going to be that way. Various extremes of elasticity. So we talk about some situations being perfectly inelastic, like totally unresponsive to price. This is a value of PED of 0. Like there's no connection between price and demand. The demand curve here is going to be perfectly vertical. Perfectly elastic, it'll be a horizontal line. It's totally responsive. Any change in price will have an infinite change. It's got a PED value of infinity here. It's obviously a sort of hypothetical extreme, but it could go that far. in theory. And then unitary elasticity is unique in its own right. That's a situation where the PED is equal to 1 all the way down the length of the demand curve. It's quite an important elasticity because it has implications for total revenue. Total revenue is maximised, for example, when PED is equal to 1. You need to be familiar with the determinants of PED, so what makes a product elastic or inelastic, and these 4 give that indication to us. So it depends upon whether there are available and close substitutes. If there are, then PED is likely to be more elastic because people can choose. Is the good a necessity? If it's not, it's going to be more elastic, more responsive. Proportion of income is how much you spend on the product. It's not the price, it's the proportion of income. And so if you spend a very small proportion of your income on this product, if the price changes, you may not notice even. And so it's going to be more inelastic as a result. And then over time, products tend to become more elastic as people start to be aware of alternatives and can shop around and find different products that they might want to buy. So there's an important connection between elasticity and total revenue, and you can basically, from the data that I've got in this previous slide, you could plot a demand curve with its corresponding total revenue curve. They would always look like this. All right, so you've got, for any demand curve that's downward sloping like this, you're going to have a total revenue curve that total revenue initially sort of goes up, reaches a maximum point, then it starts to come down. Now, actually, and this is sort of more relevant for HL perhaps, but I think even so, SLs need to be aware of it, that this point where total revenue is maximized is the point where PED is equal to 1. So the interesting thing about these demand curves that are not one of the extremes is that these demand curves, like downward sloping demand curves, will have varying degrees of elasticity all the way down their length. And so you'll have a point here where PED is equal to 1. You'll have a range here where PED is price inelastic, right? So when the price is lower down the demand curve, this will be the inelastic range. And then you'll have a range up the top end here, if you like, where PED is greater than 1. It's always the case, even with a demand curve that's still relatively steep, like this one, it will have varying degrees of elasticity down its length. And the flat ones, well, not very flat, that one, is it? But a flatter one would also have that sort of range. So the important thing in relationship with elasticity and total revenue. Now you can show it with this diagram, which is my preference, but you can also show total revenue as the area underneath the demand curve. So when the price is here and the output's here, the total revenue is shown by this area that I'm just shading in underneath that demand curve. And you can therefore, choose different prices like here, and now total revenue will change. But it's quite difficult if you're just looking at the area underneath the demand curve to sort of see whether the blue area is bigger or smaller than the red area. And it's not easy to notice. So that's why I prefer to look at it in terms of the total revenue curve being directly above the demand curve here, because what I can show is I can choose a price and see what its corresponding total revenue will be at that price. Right? And then I can say, look, what if I drop the price here? What happens to my total revenue? Well, I can see more clearly on my total revenue that when I drop the price, remember I'm in the elastic range of the demand curve. When I decrease the price here, the total revenue will go up. And the reason for that is that because the product's elastic, the percentage increase in demand that results from the fall in price will be larger than the percentage decrease in price. So with total revenue being price times quantity, that will lead to an overall increase in total revenue. Now, if I'd done a similar thing down this range, let me choose another price, an output combination, and get my total revenue point here. And now if I lower the price, what you'll notice is that the total revenue will go down. So I've decreased the price similarly to I did in blue, and now my total revenue decreases. And that's because I'm in the inelastic range of my demand curve. So here, price has gone down, but because it's inelastic and unresponsive to price change, the percentage increase in price, the percentage increase in demand that we get as a result of that decrease in price is smaller than the percentage decrease in price that triggered it. And so overall, my total revenue is going to decrease. Okay. So then finally, just a reminder that that point where PED is equal to 1 is the point where my total revenue is always going to be maximized. Now, if you look through the other slides, you can see some further explanations of why the price will lead to either an increase or decrease in revenue and might clarify what I've just been talking about. And you can also have a look at the second example as well of that explanation.